Today we look at the Russian economist Eugen Slutsky. Slutsky was born in 1880 and he died in 1948. He was a Russian-Soviet theoretical statistician more than an economist, although not necessarily so by choice. Slutsky's boss, Nikolai Kondratieff, had criticized some of Stalin's economics plans and was immediately sent to the Gulag and was later executed by firing squad. After this happened, Slutsky decided that it was safer to investigate the statistical properties of the weather than of GDP or other economic statistics. Slutsky is most famous for two papers. He was the very first to decompose a price change into the income and substitution effects. That was in 1915. This was later rediscovered by Hicks and Allen in 1934 and made famous, although Slutsky certainly has priority. You can find a description of the income and substitution effects in any microeconomics textbook, so I'm not going to go into that in this video. Instead, I'm going to focus on the second of Slutsky's contributions, which was a great paper from 1927, The Summation of Random Causes as the Source of Cyclical Processes. Let's take a look. The very term business cycle tells you something about how the early theorists of business cycles thought about what they were doing. They thought they were looking for regular, repeated patterns. So Mitchell defined a business cycle as a sequence of four phases: prosperity, crisis, depression, and revival. And he thought that these phases were intimately linked, that one led to the other, that prosperity produces conditions which lead to crises, crises run into depressions, and depressions after a time produce conditions which lead to new revivals. Now, of course, we never see a sequence of prosperity, crisis, depression, and revival quite so smooth or obvious as the one which I've drawn here. Nevertheless, when the early theorists thought about this, they thought about noise as being on top of the underlying cycle. That is, the cycle was what was real, and the noise might distort or might obscure the underlying cycle, might make it harder to see. But it was a cycle on top of noise on top of a cycle. Most importantly, the early business cycle theorists thought that to explain cycles, business cycles, you needed cycles. So to explain the business cycle, the regular recurrence, the ups and downs, they looked for variables which were also going up and down, which were also following a similar cycle, explaining cycles with cycles. Cycles were also big in Russian economics. So as I mentioned, Slutsky's boss was Kondratieff, who is still famous for Kondratieff Waves. Indeed, if you Google Kondratieff today, you get more hits than for Slutsky. And you see all of these pictures of these waves, which was a 70-year wave, which Kondratieff thought he saw in the 19th century. And people say even today you can find these waves, you can use them to understand history. It's sort of a secret guide to history of what's going to happen over the next 70 years. You can know it all before it happens. So there's still a big literature, not in academic economics, but among people trying to predict stock prices and predict the future, you can find lots of discussion of Kondratieff waves. Slutsky, however, was having really none of this. What Slutsky did in his 1927 paper is look at random numbers and some of the properties of random numbers. In particular, he started off with a set of random numbers, which he actually got from lotteries, from the last winning numbers of lottery tickets. And he took some simple averages of these random numbers. We're going to look at a 3-period moving average. Slutsky looked at a 10-period average, and he did some other variants on that. But basically, he was doing some fairly simple manipulations of random numbers. So here's a 3-period moving average. Here's our random numbers. You take the first 3 of them, and you get the average, 7.66. You then move this operator, the moving average operator, to the next 3, and you find the average of those. You then take your moving average operator, and you move it to the next 3, and you find the average of those, and so forth. Then what Slutsky did is he said, well, we know the properties of the random numbers. what are the properties of the moving averages of the random numbers? So we investigated the properties of these numbers, okay, of the moving average series. And what he found is that the moving average series was not random. In fact, the moving average series displayed remarkable patterns, patterns which were remarkably like those you found in business cycle research. Let's take a look. Here's a fantastic figure from Slutsky which really tells the whole story of the paper. The solid line here is actual business cycle data from England. The dotted line is a simple moving average of random numbers. A simple function of random numbers. And what you can see in this graph is that a simple function of random numbers can look very much like actual business cycle data. Or, as Slutsky himself put it in the title of the paper, summing of random causes, or perhaps shocks, as the source of cyclical processes. A summation of random shocks, a function of random numbers, can produce something which looks like business cycle data, which looks like actual business cycle data. Now, there are two interpretations of this rather remarkable finding. Let's take a look. One interpretation of Slutsky's results is that statistical manipulation can yield illusory cycles. Now, this is important because go back to Burns and Mitchell and the other people who were looking for this business cycle. Now, no picture is actually as smooth as this. So what did Burns and Mitchell and other people do with their data? Well, they took moving averages and other statistical manipulations of their data. What Burns and Mitchell and that group thought that they were doing is revealing an underlying cycle. By taking moving averages, they thought they were reducing the influence of noise in order to reveal the reality underneath, which was this cycle. Slutsky's results suggested that in the process of taking these moving averages, these business cycle researchers could actually be creating this cycle, an illusory cycle, but creating one. Now, this interpretation has created its own literature, which is expanded in many different directions. It goes under the name of the Slutsky-Yule effect. Yule, another statistician who looked at this. And more modern approaches, or more modern descendants of this approach, look at things like spurious regression. What happens if you regress a random walk on a random walk, you can get spurious results. So there's a whole literature on how statistical manipulation can yield illusory results, which is sprung out of this interpretation of Slutsky's results. It is, however, not the only interpretation. The second interpretation of Slutsky can be illustrated with a famous argument from the Swedish economist Knud Wicksell. Wicksell said, imagine that you bump into a rocking horse. Even though there's a one-time shock and a sort of a linear shock, the rocking horse will begin to oscillate. It will have a cyclical motion. So the second interpretation of Slutsky is that the real economy may have propagation mechanisms that act on random shocks as if they were moving averages. So rather than the moving average being a statistical property, a statistical function, instead, if we think about that as being a function of how markets work, of how the economy is organized. So a random shock may propagate through the economy as if there were kind of a moving average process, or there may be a real process which acts like a moving average. So to understand the business cycle, therefore, in this framework, you want to create a model of the random shocks and of the propagation mechanisms. And this was exactly the program taken up by Robert Lucas, and especially by Kydland and Prescott, and the real business cycle theory. So the real business cycle theorists see themselves as descended from Slutsky, as thinking about how can random shocks propagate through an economy in a way which generates the kinds of patterns we see in the actual data. It's interesting that some of the critics of real business cycle theory also see themselves as descended from Slutsky. So Milton Friedman, for example, in a comment on Kydland and Prescott, said that the math in your model is really just acting like a sophisticated moving average. So of course, when you feed random shocks into your model, then what's going to come out is something which may be cyclical, just as Slutsky demonstrated. But it's all just randomness plus some statistical illusion. Now that probably was a little bit unfair, since there are ways that one can test these kinds of things, whether other predictions of the model actually show up in the real data. Nevertheless, it's interesting that both the real business cycle theorists and some of their critics see themselves as descending from Slutsky, these two different interpretations, both of which, I might add, you can find in Slutsky's paper. Here's some further readings. Slutsky's paper, originally in 1927, reprinted in English in 1937. It's very easy to read and it's still worthwhile reading. Great paper by Kydland and Prescott in 1990, Business Cycles, Real Facts and a Monetary Myth, lays out some of the history and how these see themselves as fitting into that history. This is Milton Friedman's letter to the Journal of Economic Perspectives, criticizing Kydland and Prescott from the point of view of the first interpretation of Slutsky. And there's a book or a monograph looking at Slutsky in more detail as an economist and as a mathematician. Thanks.